Okay, picking up at number 5. If I wasn't a lazy teacher, this would be 2 rules. One for adding, one for subtracting. But I'm lazy, so we'll do it as one. The derivative of the quantity f of x plus or minus g of x is the derivative of f of x plus or minus the derivative of g of x. In words, the sum or difference of, let's try again. In words, the derivative of sum or difference is the sum or difference of the derivatives, or that is, you may break up derivatives by adding and subtracting. And what I mean by break up is if it's just adding or subtracting, we can just work term by term. So this guy right here is just adding and subtracting, 3 terms, so we just work term by term. And showing every step here, the 2 is just a coefficient, so it's just going to stay there. Multiply by the exponent, decrease the exponent by 1. The minus sign just carries over, minus x, but then the derivative of x is 1. And then we haven't done this since the very first rule. The derivative of a constant is 0. So that 0 is from the derivative of 8, which is 0. The derivative of a constant is 0. And then the answer we'd be expecting to see 10x4 minus 1. Virtually none of you are going to show me this step here, and that's fine. We want you to be able just to write down 10x to the 4th minus 1. Now, comment about this. These basic rules, pretty much by tomorrow, expect you to know the power rule. Multiply by the exponent, decrease the exponent by 1. Derivative of x is 1. The derivative of constant is 0. Pretty much you need to get those rules down instantaneously. Okay, next one. Rewrite first. Radicals are always rewritten, and we don't like variables in the denominator if we can help it. So the first thing I do is rewrite this. So that's 5x to the 1/2 minus 2/5 x to the negative 3. Where just the x knows. I don't care about the 2/5. It's just a coefficient. It's not hard. Basically, leave it alone. Plus 3x negative 1. And that is still the original. I haven't done any calculus. And a common mistake is people will simplify their original functions, and they'll have this feeling that they've done enough, and so they stop. Be sure you actually do the calculus. So now doing the derivative, the 5 just hangs out. Multiply by the exponent. Decrease the exponent by 1. Same thing on the next one. The coefficient, which is 2/5, just stays there. Multiply by the exponent. Decrease the exponent by 1. And same thing on the end. Multiply by the exponent. Decrease the exponent by 1. And then start to simplify. So that's going to be 5/2 x to the negative 1/2 plus 6/5 x to the negative 4 minus 3x to the negative 2. And then return it as close as possible to the original format of the original problem, term by term. So the first term was a radical. Return this to a radical. The 5 stays put. The 2 stays put. The negative is going to take us to the denominator. The 1/2 makes us the square root. The 6 stays put. This one had the x in the denominator, so move the x to the denominator. So x to the 4th. And then on the end here, looks pretty close to the original problem. So leave the end as it is. Okay, next one. Let's do a little rewriting here. So that's 8x to the 3/4 minus 10 times x to 0.1 plus 5. Again, still the original. Haven't done any calculus yet. So now derivative. The coefficient just stays there. Multiply by the exponent. Decrease the exponent by 1. Multiply by the exponent. Decrease the exponent by 1. And the derivative of a constant, sitting all by itself, is 0. Now, sometimes people confuse constants from coefficients. You know, This 8 and 10, they are just coefficients. We just write them down. They are, numbers in front of variable terms. Those are coefficients. But that 5 on the end, sitting all by itself, is just a constant, derivative constant, 0. And let's make this look prettier. The 8 and the 4 cancel, leaving 2. So we've got 3/2 x to the negative 1/4. And then 10 times 0.01 is just 1, so I'm just going to minus x to the negative 0.9. First term, was a radical, so let's return this a radical. So the negative exponent will drop us down, and that becomes the 4th root. And then on this one, since this was written, you got some choices here, and when they're choices, I'm not going to, really, if you make a different choice than I did, I wouldn't get upset. And I'm never going to get that upset about the way final answers should look. You always want to be sure you do basic simplification. 2 times 4 is 8. Sine of pi over 3 is square root of 3 over 2, basic simplification. But, little things like this, that if you left it negative 0.09, and somebody else did this, minus 1 over x to the 0.9, it doesn't matter that much. If I look at the original problem, I could view this as 2 ways. Positive exponent, so I rewrote this as a positive exponent. Or maybe someone else would see it as not a fraction, so should stay, not a fraction. So it really, on that last one, kind of depends on how the person viewed it. If the person viewed it positive exponent, there's a positive exponent, If someone viewed it as not a fraction, well, there's not a fraction. So there's a little leeway here, so don't worry too much about that. But you should get accustomed to understanding that these two things are the same. Okay, so this rule was about adding or subtracting. And it says you may break up derivatives by addition or subtraction, or when it's just adding or subtracting, you can work term by term. However, warning. While it is permissible to break up derivatives by addition and subtraction, the same is not true for products and quotients. When given a product or quotient fraction, first try to simplify to a non-product or non-quotient, then use the basic differentiation rules discussed so far. If it is not possible to simplify to a non-product or non-quotient, you will have to use the product rule or quotient rule, which we will discuss later. But even after we learn the product rule and quotient rule, if I can simplify first, if I can use algebra to simplify my original function, I am always going to use algebra to simplify my original function if I can. So when I look at this first problem, remember that this means x minus 3, it's a product, and so I am going to multiply this out. And so that's x squared minus 6x plus 9. And that is still the original function. But it's an original function that is more calculus friendly now. Anytime I can simplify my original functions, I'm going to simplify. And now I just use my basic rules. Multiply by the exponent, decrease the exponent by 1. The derivative of a coefficient times x, coefficient times a variable is the coefficient. And the derivative of a constant is 0. And so what do we have here? 2x minus 6. Now, if this were a test problem, what I'd be looking for is where you multiplied it out. You wouldn't show me that. That's just me reminding you that we need to FOIL it, that you would multiply it out, give me that answer. Okay, next one. Same deal. It's a product. Multiply it out. And like I said, even after I learned this thing called the product rule, I would still choose to multiply it out. Anytime I can simplify and avoid a product rule, quotient rule, that's what I'm going to do. So distributing that x to the fourth, remembering to add x, well, multiply out and simplify. Yes, I'm going to multiply out. Let's do one other step first. Let's rewrite that guy on the end as 1/2 x to the negative 9, because I really don't like variables in the denominator. And now let's distribute, remembering to add my exponents. So that's going to be 2x to the fifth minus 5x to the fourth plus 1/4 x to the fourth times x to the negative 3. Add the exponents. 4 plus negative 3 is 1 for x to the first, or x. And then plus 1/2 x to the negative 5. And that is still the original. Haven't done a lick of calculus yet. But it's now in a much more calculus-friendly format. And so I can just use my basic rules. Make that so it's actually legible. So my derivative, the 2 just stays there, multiply by the exponent, decrease the exponent by 1. The 5 just stays there, multiply by the, didn't multiply by the exponent. Multiply by the exponent, decrease the exponent by 1. Coefficient times x, the derivative of coefficient times x is just the coefficient. And then lastly, the coefficient just stays there, multiply by the exponent, decrease the exponent by 1, and now let's make it look prettier. So that's 10x to the fourth minus 20x cubed plus 1/4 minus minus 5/2 x to the negative 6. And then the only thing I would consider doing on this one as far as simplifying it is maybe dropping that negative 6 down. And so 10x to the fourth minus 20x cubed plus 1/4 minus 5 over 2x to the 6th. And dropping that x down there gives me a chance to say again, remember an exponent applies to the one factor to which it's adjacent. So that's negative 6 applied only to the x, so only the x moves. Okay, last one of these. We're at 12 minutes here. I should end this video, and then we'll do this last basic problem.